So today's video is going to be discussing the division property of exponents. So far we've done zero and negative exponent properties, and we've also done all the multiplication properties. And so it seems natural that we should be working on division properties today. By the end of the lesson, you should be able to say that I can divide powers with the same base and raise a quotient to a power. And so in the warm-up today, we're just going to go ahead and simplify this using the rules that we know. Looking at this top, anything to the 0 power is just 1. Then we have it over that 4x to the minus 3, y2, z to the negative 4. The next problem here are these negative exponents. We can't have negative exponents, so they actually have to go up in the top. And so we're going to have an x cubed times a z to the 4th all over 4y squared. There's nothing else left to simplify, and so that would be our final answer. So our first property that we're going to talk about today is the dividing powers with the same base. However, before we get this, let's think about when we multiply powers with the same base. What did we do yesterday? So if we have a squared times a to the 7th, if they have their own base, we are going to add our exponents. So we added the exponents. So our answer would be a to the 9th. So if that's when you multiply powers with the same base, what do you think is going to happen if you divide powers with the same base? Well, I'm sure you guessed it. We are going to subtract the exponents. And so we're going to take, if they have the same base, we are going to subtract our exponents. So a to the m divided by a to the n is going to be a to the m minus n. So our next property is going to be the power of a product property, is what we discussed yesterday. And now yesterday, when we had things like this example down here, remember it had us distribute the exponent. And so when we distributed the exponent, the distributive property uses multiplication. So we had a to the 6th, b to the 21. Now, today, our property is raising a quotient to a power. Remember, the word quotient means division, and it's raised to a power. So something that's divided, raised to a power. That's just like our example over here. Now what's going to happen is you are going to raise the numerator and denominator to the power, then simplify if you need to. And so what's going to happen is you're kind of going to distribute again. You're going to give the numerator and the denominator the power, or your exponent. And you're going to then simplify. So you're really multiplying, remember, just like up and top. So we would have a to the n over b to the n. We can't simplify anymore, and so that would be our answer. So, knowing the properties we discussed, we first have examples that are going to use dividing powers with the same base. Same base, and they're divided. And so when we do that, we are going to end up subtracting our exponents, but we keep our base. Our base is still going to remain 3, and we're going to have 8 minus 6. So we really have 3 squared. However, because it's a number, we need to simplify to what the number is. 3 squared is simply 9. Next example, a to the negative 1 over a to the negative 4. Same basis, that means we're going to subtract our exponents. Our base is a. We have negative 1 minus negative 4. What really happens is your negative 1 plus 4, so we have a to the 3rd power. Notice what happened here. We went from negative exponents in both of those to a final answer with a positive exponent. So we didn't really want to make them positive first. Leave them like they were, gave us the best answer. Once more, same base, subtract our exponents. So we have 8 to the 3/4 minus 1/4. Beauty is they have common denominators, so we just subtract straight across. 8 to the 2/4. 2/4 we can simplify, so we're going to have 8 to the 1/2. And then, really what this is going to become is the square root of 8, which we'll learn about later. 8 to the 1/2 is fine for today. Here are some more examples using what we've been working with. Here they have the same basis, so we're going to subtract our exponents. So I have 5/10, and then in top I'm going to have s to the -7 minus a -9. Minus a negative is really plus, so I have 5/10, and then an s squared on top. Now, we always want to simplify our numbers if possible. So I'm going to simplify my 5/10. I'm going to divide them both by 5, which is their common multiple. And then when I do so, I get a 1 on top, so just an s squared on top, and then 2 on the bottom. And that is my simplified answer. In our next example, I like to kind of group things together. So I have my numbers, I have my A's, my B's, and my C's. So I'm going to go ahead and work with these. So we actually don't need to do that. So if we take 12 divided by 4, I get a 3, and it would be in the numerator. Okay. And then also in the numerators, I'm going to put my other stuff. I'm going to have a to a -1 minus 5. And I'm going to have b to the 6 minus -1. And I'm going to have c to the -3 minus 5. Notice you always take the top one minus the bottom exponent. Top exponent minus the bottom. Top minus the bottom always. When I simplify, my 3 doesn't change. Then I have a to the -6. And I get b to the +7. And c to the -8. Now, we can't have negative exponents, so I'm going to put them down in the bottom. So on top, I'm going to have my 3b to the 7. And now on the bottom, I'm going to have an a to the 6 and a c to the 8. And that will be my final answer. Same thing with these two problems. I want you to try to do them on your own, so please pause the video and then come back to check your answer. So looking at the correct solutions, notice I grouped things and then I went ahead and wrote out my subtraction problems. I would suggest writing this out so that we don't make little math errors, because a lot of us aren't going to remember minusing the negative is going to give us a pause adding or things like that. And then for this first one, when we finally solve, we get 2 times m to the 4th over n to the 4th. And with the second one, when you end up solving, you get t to the 11th over 27m squared. Notice 3 cubed isn't simplified. You have to change it to 27. Now our next examples are going to use the raising a quotient to a power property. So remember, something that's divided raised to a power. We're going to give this power to the numerator and the denominator. If there's already powers there, you're going to end up multiplying. It's kind of like distributing. So we're going to get 3 squared over 8 squared. Because these are numbers, we need to keep going. 3 squared is 9. 8 squared is 64. Then if you can reduce, you need to. However, you can't, so our answer is 9 over 64. Next one, you have to give it to every term. Quotient to a power of 4. But it has to be every term. So you're going to give the 4 to the 3, the x, and the y. It goes to everything. So we're going to have 3 to the 4, x to the 4, over y to the 4. Now numbers we have to keep simplifying. 3 to the 4 is 81. And then we have x to the 4 over y to the 4. We can't simplify our variables anymore, so then we're done. So we have a negative. Negative's going to hang out. We have to remember, I'm actually going to give the negative to my 7 so that it's associated with something. This negative 2 exponent has to go to every single term in here. And we're going to be multiplying exponents. So we have negative 7 to the negative 2. Then we have x to the 3/2 times negative 2 over 5 to the negative 2, y to the y times negative 2. When I work with my fractions, this whole thing is going to just really become a negative 3. And so we have a negative 7 to the negative 2, x to the negative 3, over 5 to the negative 2, y to the negative 2y. Because these are all negative exponents, we need to flip this. So we need to take the reciprocal, essentially. So we're going to have a 5 squared y to the 2y over a negative 7 squared x to the 3. We need to simplify these numbers, and so we get 25 y to the 2y over 49 x cubed. And that will be our final answer. So here are 2 more examples. I want you to try them on your own, so pause the video, give them a try, and then come back. Remember, this negative out front, we like to associate it with a number so that we don't forget to deal with it. So I'm going to put it with a negative 2 in that problem. So go ahead, solve, and come back and check your answers. So looking at the work here in the final answers, there's a lot of different ways to start these problems. So if your process was different, that's okay. What we're really looking for is to make sure we get the same answers. So for this first problem, my final answer was 1 over 8n cubed. And for the second problem, my final answer was 27 y to the 12th over negative 8 x to the 1/2. And our last types of examples deal with scientific notation, just so that we know how to deal with it. So with scientific notation, it's going to be the same. We're going to first work with the numbers, and then we're going to look at the things. Same basis, just subtracting those exponents. So 4/3 is going to become 1.33, repeating, and it's going to be times our 10 to the negative 2. However, because this is scientific notation, we can actually figure out what is 10 to the negative 2. And so it's going to become, move our decimal over 2 spots, 0.013 repeating. And that would be our final simplified answer. Same thing with the next problem. We're going to be subtracting our exponents after we figure out 1.8 divided by 9. And 1.8 divided by 9 actually ends up being 0.2. And then we can do times 10. 5 minus 2 is going to be 3. And we can actually take this one step further, move our decimal 3 spaces in the positive direction, and we actually get 200 as a final answer.